Today we're doing lesson 4.22, solve problems involving large numbers. So we've done the math warm-up. Now we're on page 204, the fundraiser. A school's track teams raised $41,560 from fundraisers and concession sales. In the fall, the teams paid $3,180 for uniforms, $1,425 in entry fees for track meets, and $18,790 in travel costs. Follow along as I read. In the spring, the teams paid $10,475 in equipment replacement, $1,160 for competition expenses, and $912 for awards and trophies. Number 1 says, was the amount collected enough to cover all the payments? Explain or show how you know. So here's what we're going to do. We are going to write the word fall and the word spring. Pick up your pencil. Okay, and then I'm going to give myself a little bit of space under the word fall in case I have to regroup or decompose. And then I'm going to list the expenses from fall, starting with the biggest one. What was the biggest expense that they had in the fall? Colton?
$18,790.
Nice. Yes. So I want you to all write $18,790. What was the next biggest expense they had in the fall? Ari?
$3,180.
So I'm going to write $3,180. Make sure you line up your commas. And what was the least expense they had in the fall? Cameron?
900.
No, that's in the spring. We're talking about the fall, which is in this paragraph here.
1,425.
Very good. All right, so those are their expenses in the fall. And we need to find out how much they spent altogether in the fall. So what should we do, Jackson? Add. So we've got to add. And then let's list the expenses that they had in the spring. What was the biggest expense they had in the spring, Macy? No.
Wait, 10,475.
Yes, the biggest expense they had in the spring was $10,475. What is the next biggest expense they had in the fall or in the spring, Fisher?
4,160.
Yep. And so we got to line that up correctly. And then the least expense, the smallest expense they had in the spring, Athena?
$912.
That's correct. All right. And so then we're going to add those numbers up. Then we'll have how much they spent in the fall, how much they spent in the spring, and we'll have to combine them and see if their amount of money that they took in from the fundraiser and concessions was enough to cover their bills. All right, so here we go. What is 0 plus 0 plus 5? 5. Let's do 5. And then when I'm adding a group of numbers, I always look for chunks of 10. So you see 8 plus 2 is 10, plus 9 more. 19. So we put down the 9, carry the 1, Athena. So this is something that you're having a little bit of trouble with. So make sure, so think about 19 for a second. You always want the ones place to go down and the tens place to go up, okay? And then we have 7 plus 4, which is 11, plus 1 is 12, plus another 1 is 13. Down the 3, carry the 1. 8 and 3 are 11, 12, 13. Put down the 3, carry the 1, and then 1 plus 1 is 2. So in the fall, they spent a total of $23,395. And then in the spring, what is 5 plus 2? 7. And then 7 plus 6 is 13, plus 1 more is 14. Put down the 4, carry the 1. 9 and 1 make 10, plus 4 more is 14, plus 1 is 15. Put down the 5, carry the 1. 1 plus 1 is 2, and 1 plus nothing is 1. So in the spring, they spent $12,547. So now we've got to find out how much they spent all together, which means we need to do what? Devin?
Decompose.
No.
Dang it.
Autrey?
Add our answers together.
Add our two answers together. So 23,395 plus 12,547. So now what is 7 plus 5? 12. Put down the 2, carry the 1. 9 and 1 makes 10, plus 4 more is 14. Put down the 4, carry the 1. 5 and 3 makes 8, plus 1 is 9. And then 3 plus 2 is 5, and 2 plus 1 is 3. So their total expenses, the total amount of money that they paid out, was $35,942. Did they have enough money to pay their bills?
Yes.
Yes, because what they took in was $41,560.
Wait.
So our answer is yes, because 41,560 is greater than 35,942. All right. Then the last question on this page, what, Macy? You put it on there? Hey, just a moment. It says if the amount collected was enough, which it was, they had enough to pay their bills. It says how much money did the track teams have left after paying all the expenses? How would we find that out? Emma? We would have to subtract, right? And if we're subtracting, what number always goes on top?
The bigger number.
The bigger number. So on top, we're going to write 41,560 minus 35,942. Honey, you got to keep up so you don't have to spend your pirate time catching up. All right. 0 minus 2.
Can't do it.
Can't do it. So we have to go decompose the 6 and make it a 5. Make the 0 a 10. 10 minus 2, 8. 5 minus 4,
1.
5 minus 9,
Can't
do it. So we decompose the 1, make it a 0. Make the 5 a 15 minus 9, 6. 0 minus 5,
Can't do it.
0 minus 5 can't do it. or decompose the 4, make it a 3, make the 0 a
10.
10 minus 5, and 3 minus 3,
0.
so we don't need that 0 in the front. So the amount of money they have left over is $5,618 left. So that's how much they have left. Okay. Now, in just a few minutes, I am going to give you guys a pack of cards with 10 digits in it. It's going to have a 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. And you are going to put those digits in in some boxes. So go ahead and look at page. Don't turn the page. You are on the right page. Leave it alone. Okay, what is it?
205.
205. Okay, here we go. So I want you to all put your pencils down for a second because I'm going to give an example for the people that are watching the video to write down because they're not going to have the cards. But I'm also going to show you guys how to do this problem. So the directions say, your teacher will give you and your partner a set of 10 cards, each with a number between 0 and 9. Shuffle the cards and put them face down. Then draw 3 cards. Use all 3 cards to form 2 different numbers that would give. And then you follow the directions. Okay, so let me tell you that the 3 cards that you use, Evan, for this page, those are the only 3 numbers that are going to go in these boxes. Okay. All right, so back in business. Okay, so I'm going to give you some cards. Okay. You're going to choose 3 cards. I want you to choose different ones than I choose. It's okay if you have some of the same numbers, but I want you to have at least one different. All right? Stop. You're fine. Okay, so I'm going to use the cards. A card that is a 2, a card that is a 4, and a card that is a 5. Okay, so from my stack, I pull out a 2, a 4, and a 5. Got it?
Yep.
Okay, so it says I need to use those cards to form 2 different numbers that would give the greatest possible sum. How would I make the greatest possible sum, Harbor? With a card that has a 2, a 4, and a 5 on it. Yeah, so what would that be?
5, 4, 2.
Yes, so my first number would be a 5, then a 4, then a 2. I want the 5 in the biggest place value.
5 is the bigger number.
5, 4, 2. And then I've got to have a different number to add to it. What's the second biggest number I can make with a 5, a 4, and a 2? Jackson.
4.
Mm-mm.
524.
Yes, there you go. 5, 2, 4. So I want to keep the 5 in the hundreds place, right? Because it's the biggest place value. Is 542 and 524 a different number?
Yes.
Yes. Okay, so then we would add those together. Then it says the least possible sum. So what would be the smallest numbers that I could make with a 2, a 4, and a 5? What would be the smallest number? Macy?
2, 4, 5.
Yep, 2, 4, 5. What would be the second smallest number, Zerelda?
2, 4. Second small. 2, 4.
No, PR2.
2, 5, 4.
Yep, I would have to flip-flop the last 2 digits, right?
Mm-hmm.
Okay, so this spot is for your biggest number. You can write this part down. This part is for your second biggest number. This space is for your smallest number, and this is for your second smallest number. Okay, and then down here, it wants the greatest possible difference. So using these 3 cards, what is the, and subtracting, how can we get the biggest difference? The biggest difference. Jackson?
By subtracting the biggest and the littlest.
Nice. I clean my hands, very good. The greatest minus the smallest. So this is going to be the spot for your biggest number. This will be the spot for your smallest number. And the biggest number was 542, and the smallest number was 245. And the last task is to find the least possible difference. So the smallest difference that you could find using those digits. Jackson?
245 minus 542.
No. Audrey?
It would be 254 minus 5.
No. Avis?
254 minus 245.
Yes, we're gonna find the difference in our 2 smallest, right? So we're gonna find, so this, the same numbers that I wrote right here are gonna be down here, only they're gonna be flip-flopped. Because when you subtract, you always have to have the bigger number where?
On top.
On top. So it's finding the difference in the 2 smallest numbers that we have. Make sense? Okay, so, and then you'll have one more page where instead, so this was the smallest and the second smallest. And then on the next page, we're gonna have 4 cards. And so I'm going to just add in a 8 to this mix. Okay, and again, you can use some of my numbers. I just don't want you to use the exact numbers. You with me? Mm-hmm. What? Okay. All right. So if you have 4 cards, you've got these 4 cards. What would be the biggest number that you can make with those cards? Todd?
8,542.
Nice job, Todd. Yes. 8,542. What would be the next biggest number you could make with those 2 cards? Ari? Nope. Haziel?
8,200.
What did you say?
8,200.
Nope. Davis?
8,524.
Yes. You just flipped the last 2. Does that make sense? Okay, so you're going to do 8,500. Keep the biggest place values with the 2 biggest.
Wait, are we writing that?
And nope,
No,
you're not
okay.
writing these numbers. I'm just showing you how to do it. Again, this will be the biggest number and the second biggest. Okay, and then least possible sum. What's the smallest number you can make with these cards, Emma? Yep, they're already in that order, right? 2,458. Cameron, what would be the next smallest?
2005.
Yep.
2008.
Yep. Evan?
2005.
Yep.
Wait, 2000.
I know.
2,485.
Yes. Keep those two biggest place values the same. Okay. Then the greatest possible difference means you take the biggest number minus the smallest number. And then the last one, you take the second smallest minus the smallest.
Do we write that?
I would suggest you do that, yes. Okay.